For nearly a century, we treated Pluto as a footnote, a frozen leftover too small, too far, too irrelevant to matter. So irrelevant that in 2006, we voted to strip away the one title that made it famous. Case closed. Story over. Except starting in 2022, the James Webb Space Telescope gave scientists an entirely new way to study that irrelevant world, a way to read its atmosphere without ever leaving Earth's orbit. And what it revealed was a set of clues pointing to something happening in Pluto's sky that nobody had fully understood before. The story of how we got here starts with a 24-year-old farm boy in Arizona, comparing photographs of the night sky by hand, night after night, searching for a single point of light that had moved. Most nights ended in nothing. Then one did not. A tiny dot shifted position against a field of fixed stars, and that dot became Pluto, the same world that schoolchildren would grow up memorizing as the ninth planet became the first planet-like world humans ever discovered, and then lost. Because in 2006, a single vote by the International Astronomical Union erased 76 years of that identity. The only world in astronomical history to be discovered, celebrated, and then formally demoted from the category that made it famous. For most of the 20th century, that felt final. Pluto was small, cold, and irrelevant. Case closed. Except the case was about to reopen in a way nobody expected. In 2015, after a 9-year journey across billions of miles of empty space, NASA's New Horizons spacecraft screamed past Pluto at more than 30,000 miles per hour. It had one shot, no orbit, no second pass, just a narrow window of a few precious minutes to capture everything it could before continuing on into the darkness forever. What it sent back rewrote everything we thought we knew. A massive, pale, heart-shaped plane stretched across the surface, smooth and strangely young-looking against ancient cratered terrain. Mountains of solid water, ice rose thousands of feet into a thin, hazy sky, frozen so hard that it behaved less like ice and more like bedrock. Fields of nitrogen churned slowly in giant convection cells, resurfacing themselves from below. Pluto did not look like a leftover. It looked like a world still in the process of becoming something. But a single flyby could only raise questions. It took Webb, reading the exact chemical fingerprint of light itself from 4 billion miles away, to start answering them. Pluto's atmosphere is wrapped in a thin blue haze. Scientists once assumed that haze worked the way it does on Saturn's moon Titan, trapping heat, warming the surface below. Webb's data suggested the opposite, that haze may be absorbing sunlight and firing that energy straight back into space, faster than the thin atmosphere can hold on to it. Scientists believe Pluto's atmosphere may be cooling itself in a way unlike anything else confirmed in our solar system. And the cold this creates is almost impossible to picture. Sunlight at Pluto's distance is 1,000 times fainter than on Earth. Surface temperatures sit nearly 400 degrees below zero, cold enough that nitrogen, the very gas filling your lungs right now, freezes solid into the landscape itself. Imagine standing there. The sun would still be visible, but only as a piercing point of light with no warmth and no glare. The ground beneath your boots wouldn't crack like ice. It would ring like struck metal. Yet Pluto's biggest secret may not be happening in its sky at all. It may be happening where no sunlight has ever reached. Deep beneath Pluto's crust, patterns in the ice suggest something almost impossible. A hidden ocean, kept liquid by radioactive heat, sealed away in permanent darkness 100 miles down, untouched by light, untouched by time for billions of years. Cracks and ridges on the surface line up in ways that fit a subsurface layer of liquid shifting beneath the crust. If that ocean is real, it exists without any direct connection to a star at all. One of the strangest possible environments for the basic conditions life requires, anywhere in the solar system. Some material still escapes upward, though. Faint sunlight is enough to shatter methane molecules into heavier compounds. The same class of organic chemistry some scientists believe helped spark life on early Earth. On Pluto, that process has run undisturbed for 4 billion years. A slow, continuous snowfall of biological building blocks drifting onto a surface too frozen to ever use them. Some of that material doesn't stay. It leaks past Pluto's weak gravity into space, drifts across 12,000 miles, and lands on Pluto's largest moon, Charon, staining its poles a deep reddish-brown, darker than anything else on the moon's face. For decades, researchers suspected a connection between the two worlds but lacked the tools to prove it. Webb provided that proof. Escaping molecules from Pluto's atmosphere are captured by Charon's gravity, frozen onto its surface, and broken apart by sunlight into the same compounds that color Pluto itself. Two worlds quietly trading atmosphere and color for longer than either has had a name. We have no spacecraft plan to go back and confirm any of it. No lander, no orbiter, nothing currently funded. For now, Webb remains our only witness, checking in every few months whenever Pluto swings back into view, adding one more piece to a puzzle that keeps getting stranger, not simpler. And Pluto isn't alone out there. It sits inside the Kuiper Belt, a vast ring of icy debris beyond Neptune, home to hundreds of thousands of objects and an estimated trillion comets. If one frozen, demoted, irrelevant world was hiding chemistry like this, a possible ocean like this, an atmosphere behaving like nothing else we've confirmed, there's no reason to think it's the only one. Because Pluto taught us something unexpected. The edge of our solar system is not where the mysteries end. It's where they begin.